Hi everyone, how are we doing? So what I want to do now is explain the natural rate of output, or the long-run aggregate supply schedule. So, natural level of output, we also call it long-run aggregate supply. So, and here we have the natural level of output in 2015, 16, and 17. So what we're arguing is that over time, the natural level of output grows. And it grows because of changes in technology, TFP. So as technology improves, that means that the firms can take the same amount of labor and capital and produce a greater amount of output. So what we can see is that as technology grows, the natural level of output is going to grow over time. And that's what we call it LRAS, LRAS prime, or LRAS double prime. So that's the types of designations we use for it to be changing over time. Now, besides technology, also increases in population. As more people are born, more people enter the workforce, the natural level of output will also grow over time. And remember, the natural level of output also reflects an increase in capacity of what the economy can produce. And the third factor is the capital stock. As more buildings are produced, more hospitals, more business offices, more retail, more grocery stores. As the capital stock increases, the long-run aggregate supply schedule also shifts outward. So, when we talk about long-run aggregate supply, we're also talking about the natural level of output. Okay? So, these curves grow over time. So now, I've given you an example of in our total model about what an impact of the long-run aggregate supply schedule shifting outward implies. So, if we start at LRAS, and we're starting at the natural level of output YN, and we have a price level P0, and again, this intersection point right here is long-run equilibrium. I did not designate it with E, I just wanted to keep the graph a little bit simpler. So, here we're starting at this point right here. Now, if there's an increase, let's say, in technology, what's going to happen is the long-run average supply schedule is going to shift outward to YN prime or LRAS prime. But at the same time, if there's an increase in technology, that also reduces the cost of reductions for firms. So, as the long-run aggregate supply schedule shifts outward, the short-run aggregate supply schedule also shifts outward, reflecting that firms are benefiting from an increase in technology. They can take the same amount of labor and capital and produce a greater amount of output, which implies also that the cost of producing output is falling because the same amount of labor and capital can produce a greater amount of output. So, if there's an increase in technology, this curve is going to, long-run aggregate supply schedule will shift outward, but also the short-run aggregate supply schedule will shift outward as well. And what you have is, in the new long-run equilibrium, we have a fall in prices and an increase in output. In this case, an increase in the natural level of output. So, what we're doing is, we're assuming that there's a change in the natural level of output, and therefore we move from this intersection point to that intersection point. So, what we're just modeling is, if there's an increase in technology or the other two, population and capital stock, both the short run and long run aggregate supply schedules will shift outward. Now, it's also the case that with more people and more technology, the aggregate demand schedule may shift outward. However, for the purposes of this class, when we look at changes in these factors, we're not going to have the aggregate demand curve shift outward, even though it most likely does, but we want to keep things as simple as possible. So, to summarize, an increase in technology is going to cause the long-run aggregate supply schedule to shift outward, and ultimately it causes prices to fall from P0 to P1, but the natural level of output to rise. Okay, we'll see you in a little bit.